Questions? Yes.
Is this source delivering or?
No. When you don't have negative sign, it means it's not delivering. Okay. This is the direction of the power supply. And what is in this direction voltage is rising or dropping? Dropping. So that's why you don't have negative sign. But if it is in the direction of voltage rise, as you see over here, so it means it is delivering. That's why you have negative sign. System problem 4.2. Again, use the node voltage method to find V. What is V? From this point to this point is V. Okay? For this circuit. How many essential nodes? 2 or 3? 1, 2, 3. This one is reference. Okay. So it means we need to have two equations. For the first node, this one is entering minus 4.5 amps. That's why because entering, that's why we have minus sign over here. Plus V1 minus 0 over 1 plus V1 minus V2 over 8. Whatever resistors you see in series, one is 8, one is 6, one is 2, the equivalent resistor for these two resistors in series will be 8 ohms, equal to 0. For this node, V2 minus V1 over 8 plus V2 minus 0 over 12 plus V2 minus 30 over 4 is the current for this part of the circuit. So you have two equations, this one and this one. So solve it first for V1, you get 6 volts. Again, substitute 6 volts into this equation, you get V2 18 volts. So how do you calculate V? V, this is the current from V1 to V2. So the current from here to here is V minus V2 over 2 is equal to V1 minus V over 6. Because this is one current. Is that clear? Yes? Okay. So from here you have V1, you have V2, so you can easily calculate V, which is 15 volts. System problem 4.3. Again, use the node voltage method to find the power associated with each source. So when you say each source, how many sources do you see? How many sources? 3. 2 independent sources and 1 dependent source. Okay. How many essential nodes? 3. 1, 2, 3. So we consider this one as a reference node. So for the first one, we call it V1 and this one V2. V1 minus 50 over 6 will be the current in this branch, plus V1 minus 0 over 8, plus V1 minus V2 over 2, minus 3I1, because this current is entering this node. That's why I put minus 3. For writing node voltage, I explained, you assume that the currents are leaving. Yes, but when you want to calculate I1, you say I1 is 50 minus V1 over 6. Is that clear? Okay, one more time, for nodes, you assume that the currents for the branches are leaving unless you have current source, as you can see over here. So current source, because this is entering, you put minus 3. For this one, voltage is V1 minus 50 over 6, which is minus, you can say this is minus I1. Okay? If you want to write 50 minus V1 over 6, you have to write for this one V2 minus V1 over 2, and you should say this one plus. It means like you multiply the equation by negative sign. Okay, and what is I1? 50 minus V1 over 6. Clear? For the second iteration here, okay, V2 minus V1 over 2 plus V2 minus 0 over 4. Now I have current, power supply. So I put minus 5 because it's entering. And this one is leaving, that's why plus 3I1. So you will get two equations with two unknown variables. V2 16 volts, V1 32 volts. I1 is 50 minus V1 over 6. So what is the value for V1? 32. You will get 3 amps. How about power for 50 volt power supply? Again, V times I. Why do you have negative sign over here? The direction of I1 is in the direction of voltage rise. That's why I have negative sign. For P, 3I1, this one. What is the voltage across 3I1? Power supply, this one. How much is the value for V1? V1 32, V2 16. So V1 32, V2 16. So what is the direction of voltage rise? 32, 16. So this is like plus and this is minus. So direction of current is in the direction of voltage rise. That's why I need to add minus sign. Clear? Questions? And for the last one also the same, for 5 amp, which is this one.